Okay, applications, so they really do have applications, right? Like it's actually true, real world stuff, right? And one of the things we saw was like the road grade, right? Where you're gonna make that into a quadratic. The sum of 2 times one integer and 3 times a larger integer is 11. When the square of the smaller is subtracted from the larger, the difference is 1. Find the integers. Okay, so the last sentence of a word problem generally tells you what it is you're supposed to find, right? In this case, pretty odd, find the integers. So what are we going to start with? What should I, first thing I should write is, nope. Find the integers. What integers are we trying to find? What do we know about these integers? No, you're going into too much detail. One of them is smaller, and one of them is larger. So what are we going to call the smaller integer? X. So we are going to start off with, let x be the smaller integer. Right? So before I can do anything with the relationship between the smaller and the larger, I need to have a smaller integer. And what else are we going to say? Let y be the larger integer. Now you don't have to use x and y, you could use L and W, but that really implies length and width. It'd be sort of silly, but it wouldn't be wrong. You could use P and Q, but you can use any letters you want. Because now what I'm looking for is, okay, now there should be some relationship. So what have we got? The sum of 2 times one integer and 3 times a larger integer. So how does that translate into math?
2x.
Yeah, so we've got 2x plus 3y, so the sum of 2 times one integer, we don't even know which one this is, and 3 times a larger, okay, now we know this is the smaller. So 2x and 3y is, so how do I write it in is? Equals, right? Yeah, that's how we write is. The word is in English is the equal sign. I mean, that's just English, right? I mean, 2x is just shorthand for 2 times x. Anyways, when the square of the smaller is subtracted from the larger. So when the square of the smaller, that's x squared, is subtracted from the larger, so well, I'm going to subtract it from, so let's go y minus x squared, because if you go x squared minus y, it's wrong. Y minus x squared is 1. Okay, so look back. When the square of the smaller is subtracted from, so the square thing, the thing that's being squared, has to be subtracted from something, right? So it's got to be y minus x squared equals 1. Find the integers. They're right there. Okay, they're not right there. So, how are we going to solve this? Substitution, right? It doesn't have to be. It has to be substitution. It doesn't have to be. You can do it by elimination. You just multiply the second one by 3, right? But it begs for substitution. First of all, that gets rid of the negative x squared, right? We just get y equals x squared plus 1. Okay, so we are going to solve 2 for y. So what is y? X squared plus 1. Okay? And if you look at my paper when I've done the thing, it'll say solve 2 for y, right? I'm telling everybody in the world. Right? And if you're going to come and look at the solution, I want you to be able to look at this and say, what's going on here? Okay? And if you write that down, you're communicating. This is what's good. Do you need it? No. I don't see solve 2 for y. I'm like, oh, half mark off. You don't need that. But okay, substitute. Since we're doing substitution, substitute x squared plus 1 for y in number 1, right? Because if we stick it in 2, we're just going to end up with 1 equals 1, which, while true, is not helpful. Okay, so what's 1? So we got 2x plus 3y equals 11. So 2x plus 3, and y is x squared plus 1. Okay, so we have done a direct substitution. Wherever we see y, we are now writing x squared plus 1. We're now going to expand this. Watch very carefully. This is a plus sign. It's not a big deal, right? But you do have to distribute the 3 through the brackets. If it's a minus, just make sure you're also changing signs. But it's not. Okay. Obviously, it's a quadratic, so we might as well bring the constant over to the other side. So we've got it equal to 0. You will never solve a quadratic unless it's set to 0. So 3x squared plus 2x minus 8 equals 0. They're integers, so if they're integers, then this expression has to do what? It has to factor. Three x, 8, 4 and 2? No, 2, 6, yeah, 4 and 2. Plus and minus. Then what must you do? Gotta check it, right? I mean, if it's wrong, then we're going to reject one of the solutions because it's not an integer, right? 2x minus 4x is 4/3. Not an integer. Not interested, right? But that's getting ahead. Okay, we good? So we got 3x squared plus 6x minus 4x minus 8. If you're going to mess up anything, what is it? It's the sign, right? You're going to end up with 3x squared minus 2x minus 8. And if you're not paying attention, you're going to end up with 3x squared minus 2x minus 8, and it's just going to be wrong. Okay. All right, so what's x? 4/3. Must be an integer, right? Or what's x? -2. Okay. We good? You tell me. Is that it? We stop there? No. Okay, we got to say what the integers are, right? So the integers are -2, and yeah, we got a kind of handy expression here, right? What's the other integer? The larger one. 5. Okay, 2 times -2 is -4. 3 times 5 is 15. -4 plus 15 is 11. 5 minus -2 squared is 5 minus 4 is 1. Boom, done. Okay, check. Where'd you get 5 from? I stuck -2 in here and decided not to bother showing it because it's. So at some point, if you want to show it, great. I got bored. I just looked at the answer. You said the integers are -2 and 5. I looked back and I saw work that looked something like mine, and I said, good enough. What's the word? 3? Here, you have 3. Okay. Seriously, you think I'm going to go through every single line? No, right? I mean, so what'd you get for an answer? Do you have something that looks, does your solution look at a glance? Does it look like that? Yeah, I see a 3x squared plus 2x minus 8. I saw you factored it. I see that you rejected one of the solutions because it's not an integer, right? If you go and state the other solution, which you can find, I'm going to ding you half a mark or something. It's like, no, it says they're integers, right? Remember the 4-step problem solving method. Understand, what are we trying to do here? We're trying to find the integers, right? Word problems always tell you in the last sentence. Here's what you're doing. Then what? Well, they got information. All right, so what am I going to do? I got to say this is my smaller integer, this is my larger integer. Now I have 2 relationships that give me 2 equations because it's all about a system of equations. We're going to get 2 equations. How am I going to solve that? All right, decided on substitution. Why? Because I've got a y by itself, so it makes it easy, right? Substitution is very simple, and it gets rid of a -x squared, which is always a good thing. So that's my plan, right? System of equations. Do it. I did it. Look back. That's not an integer. It's gone. These are, right? What's that other integer? Well, it's 5. Okay, then I go back here. Well, actually, I like to go back here. Not even back there, right? What if you got that wrong? So the sum of 2 times one integer, 2 times this, and 3 times the larger integer. So negative 4 plus 15 is 11. When the square of the smaller, 4 is subtracted from the larger. So 4 is subtracted from 5. 5 minus 4 is 1. Okay. Questions? Easy peasy. The area of a circle is 4 times the circumference of the same circle. Find the radius, circumference, and area of the circle. Okay? So what's a good starting point?
Go back to geometry.
Well, draw yourself a little circle, right? You don't need one. That's not even a circle, but whatever. So it's got a radius. Area is pi r squared. Circumference is 2 pi r. So I'm putting down formulas that I should know. In this case, it's okay to use circular reasoning here. We're just reasoning about a circle.
Yeah, it should be organic.
Normally, circular reasoning is not going to win you the argument. The area of a circle is 4 times the circumference of the same circle. Okay, so area is 4 times circumference. Now, I have expressions that I can substitute there, right? So the area, it says find the radius, circumference, and area of the circle. So the area is what? What am I going to do with that A? I'm going to turn it into pi r squared, right? Because this says wherever you see A, you can write pi r squared. Or wherever you see pi r squared, you can write A. What am I going to do with the C? And replace it with 2 pi r. So this method of solution is called comparison. It's solving by comparison. It's kind of a substitution thing, right? Because we've written A equals 4C, and then we've substituted for both A and C, and now we have an expression which can be solved, right? We're going to solve this for R.
Where did 4C come from?
The area of a circle, big A, is 4 times equals 4 times the circumference of the same circle, C is equal to 2 pi. Okay? So this is method of substitution, right? I'm just substituting for A and for C. It's also called the method of comparison because we know these two things are equal to each other, so we can compare them. Okay? Good. What's the next step? Yeah, expand. Okay, so pi r squared is equal to what? 8 pi r. Right? Ooh, big step. But you got to do it. Right? Now what? It's a quadratic, right? Remember, we're solving for r.
Oh, make it equal to 0.
Make it equal to 0. Best bet, make it equal to 0. Now, what do we know about radius? It must be positive, right? Because it's a measurement, right? And if we're solving for r squared, we know that we will get a negative value for r, which we shall write down and then cross off, showing that, yeah, we've done it. Look, there it is. And no, it's not a valid measurement in the context of the question. Okay, best way to solve one of these guys, if you divide both sides by r, you could be leaving out an answer that's an answer, right? So you don't really want to do that. You really do want to do it as a quadratic. So go pi r squared minus 8 pi r is equal to 0. Is there a common factor between pi r squared and 8 pi r?
Pi r.
Pi r. Pi r a common factor. Oh, sorry. Pi r is a common factor. Look, it's Pi Day Eve.
Pi Day.
Pi Day, yeah, we don't get to celebrate Pi Day, like not together because it's tomorrow, but pulled this out of the plastic bag yesterday, right? I ordered it in the summer. I just saved it for such an I almost didn't wear it. It's like, oh my god, I missed it. Okay, what do we got? R minus 8 is equal to 0. Okay, what's the next step? Divide both sides by pi, right? Because what is pi? It's a constant. It's a number, right? It's like 5. So we can divide both sides by pi. r times r minus 8 equals 0. So either the radius is 0, what do we do with that? Can't be 0, right? Or the radius is 8. So we go up here and we say the radius is 8. What did it ask us to find? Oh, radius. And it asked us for the circumference. The circumference is 16 pi. So I'm going to leave it in terms of pi. I didn't really say, right? I didn't say, so that's exact, right? 16 times pi is exact, and 50 point whatever that works out to is not, but it, so I'm going to leave it. 60 pi. And the area is what? 64 pi. I wanted to hit Control Z. The area is 64 pi. Okay, before we do anything else, everybody okay with those? We need to do this. Okay? So that way I think it's a question you answer. Yes.
Yeah, I have that point.
Okay. You go. We'll wait for you. Okay, so everybody good with the radius is 8, the circumference is 16 pi, and the area is 64 pi. Okay? Nobody's saying, wait, how'd you get 64 pi? So let's go back. The area of a circle is 4 times the circumference. Is 64 pi 4 times 16 pi? Or what's 4 times 16? 64. Okay, so that works. Fine, and that's it. Well, that's all we needed, right? So it checks itself almost. Okay, and that's better than having whatever 16 pi is rounded to however many decimal places you round it to, right? Because we can see, look, 16 times 4 is 64. So 64 pi is 4 times 16 pi. Okay, good. The perimeter of the right triangle shown is 36 centimeters. The area is 9 more than 3 times the hypotenuse. Find the lengths of the sides, perimeter, and area of the triangle. It's like, wow, find everything. Okay, what are we going to do? So we don't need to draw a diagram, right? It's there. We don't need to say what our variables are. They're there. So what are we going to do with the perimeter is 36? What are you going to write?
2y plus 1 plus 2x plus 2x minus 3 equals 36.
Yeah, so perimeter is distance around, right? So it's just add up, right? So we're going to go 2x note the use of parentheses, which you don't need to use. But I like it, right? Because it sets aside the 2x minus 3. And when you see that line, you say, oh, okay, that's that left side there, right? Okay, cool. The 2x, by itself doesn't really need parentheses. Do they make any difference? Not in the slightest, right? Because there's no numbers in front, there's nothing to do. Okay, the area is 9 more than 3 times the hypotenuse. So how do we do that? What's the area of a triangle?
1/2 base times
1/2 base times
height.
height. What's the base? What's the height?
2x.
2x is the base. 2x minus 3 is height. All right, so let's write down A is equal to, let's do it this way. B, now let's do it this way. 1/2 base height, which is 1/2 2x and 2x minus 3. Okay? So, did I have to write out that formula? I don't know. Wouldn't really change the answer anyway. But if somebody's looking at it, they're going to say, okay, you wrote a formula for area, and I now know that you think the base is 2x, and you think the height is 2x minus 3, right? That's what that's saying to me, is I think that this is, now if that's wrong, then at least I can point you to that and say, no, you use the hypotenuse as the height or something, right? So it doesn't match up. But anybody looking at that now says B is 2x and H is 2x minus 3. Okay, there is 9 more than 3 times the hypotenuse. All right, so I've got an area thing. The area is, so A is 9 more than. How do you do 9 more than something? You add 9. So here, at the end, we're going to add 9. 9 more than what?
3 times 2y.
Yeah, so 3 times, and in parentheses, right? 3 times that expression, right? Otherwise, you'll end up with 6y plus 1. And okay, the area of the triangle is that. All right, do we have 2 equations? I've got like 6 equations up there. Find the length of this. Okay, so what are we going to do now? So we haven't done too much thinking, right? All we've done is just sort of translate what's in the perimeter is 36. Okay, got an expression for that. The area is 9 more than 3 times hypotenuse. Got an expression for that. So where do we go from here? So what's A? Oh, well, so then what I'm going to do is substitute this down here, right? So that I can say this is equal to this. And I'm going to clean this up. And then I will have, that'll be my 2 equations, right? Okay, so here's our 2 equations. We need 2 equations. Okay, so one of which is 2x plus 2x minus 3 plus 2y plus 1 equals 36. Now all I've done is remove the brackets. Now I'm going to collect like terms. So what do we got? 4x plus 2y minus 2. Let's go minus 38 equals 0. Is that a good move? I don't know. It was a move. I might regret it, but it's okay because I have an eraser handy. The question there really is, do I want to make that 0? Would I have been better off just leaving it as 4x plus 2y equals 36, or 4x plus 2y minus 2 equals whatever? Okay, the other equation is, I'm going to say 1/2 of 2x times 2x minus 3. That's what A is. But A is also 3 times 2y plus 1 plus 9, right? It's 9 more than 3 times the, okay? So we're going to clean this up. So 1/2 times 2 is 1. So I've got x times 2x, which is 2x squared, minus 3x is 6y plus 3 plus 9. Okay, so I got 2x squared minus 3x minus 12 minus 6y is 0. Okay, so I've collected terms and I've moved the right side over to the left side. Okay, so I added 3 and 9, got 12, subtracted 12 from both sides, subtracted 6y from both sides. Was that a good move? I don't know, maybe, maybe not. Okay, solve this. How are we going to solve this? We can use elimination, right? We've kind of used substitution up here, but that wasn't to solve. That was just to get an equation. All right, so I'm going to take, all right, hang on. We could divide this through by 2, right?
Yeah.
But if we did that, we'd still have to multiply it by 6 to get the 6y. So, and we can't divide that by 2. So, okay, here's what we're going to do. Let's call this 1. Let's call this 2. So I got a negative 6y. This will be a positive 6y. We're going to add, right? Adding is nice. So I'm going to take 2x squared minus 3x minus 12 minus 6y equals 0. So that's equation 2. And what are we going to do with equation 1? We're going to go 3 times equation 1, right? And multiply it by 3. And we're going to line stuff up, right? So I've got a 12x. We're going to line that up with the x. I got a 2y. We're going to line that up. And 90 and 24. What's that? 114? and I've got a minus 114. So we're going to line that up. In retrospect, putting the constants at the end might have been better for the other equation, I guess. Well, that doesn't matter. Or not putting the y's, whatever. Okay, we good? Us being good doesn't mean that you can sit there and say, if that question appears on the test, I'm good, because I've seen it done, right? You have to do some of these yourself, right? I mean, otherwise it's just a recognition depression thing. I recognize that. I wish I had done one or two. Oh, and that's equal to 0, right? Okay, now what? We add, right? We are eliminating the y. We have opposite signs, so we add. So we get 2x squared plus 9x minus 126 is equal to 0. Okay? Remember, correct any errors I make along the way. I'm not actually trying to, but you know, I'm not doing any on purpose. If I do them on purpose, I'll usually wait a while. Because I want you to say, shouldn't that be the integers? Well, I don't even know what we're finding.
We're finding the.
Oh, we're finding x and y, so we can negate the perimeter and the area and you know, when you get down here, it's as if I don't even know what the problem was, right? What's the problem? I don't know. We're just doing stuff, man. Let's just do math. Okay, well, let's try and factor it. Phew, 126 and 9. So numbers got to be relatively close together. What's the square root of 126? Like 11-ish. So, yeah, I don't know. This is where, you know, calculators are kind of handy. You could actually graph that, find the solutions, and then backwards work your way to the factors, right? You know, if it does in fact factor. Anybody got a factor? 126. What goes? 6 goes into that, right? How many times? 6, 21. 6 and 21. Can I do a 21 and a 12? Get a 9? No, 6 and 21. No, 12, 21. Yeah, actually that'll work. So a 6 and a 21. And I need, that'll give me, so that'll be a plus and a minus. I think that's it. What do we got? 2x squared minus 12x plus 21x is plus 9x minus, hey, whew. Pull that one. I've actually got an answer sheet there, but it's turned over. It's on the other side. Right? All right, so what's x? X is equal to negative 21 over 2. Now, keep in mind that one of the lengths is 2x, right? So you can't have a length of negative 21. Right? Context. So what's x? 6. Oh, wow. What's... How does that saying go? Yeah, when you're up to... Okay, so we've got this. Somewhere there's a simplified form of that, right?
Yeah, we need to.
Yeah, we need to get y. Okay, so we're going to go, let's go into here. This one's probably easier, right? Okay, so we're going to substitute, so we're coming back up here. So we're going to substitute 6 for x in number 1. So 4 times 6 plus 2y. I'm going to write equals 38. Okay, so that 24 plus 2y is 38. 2y is 14. Y is 7. Okay, so the solution point is 6, 7. But we were asked to find the lengths of the sides of the triangle. Okay, so we now know x. So this is 12. This is 9. And this is 15. Now, one thing we could check is, what's 9 squared plus 12 squared? Well, that's 81 plus 144, which is 225. What's 15 squared? 225. So we do have a Pythagorean triple, right? Like the numbers we found do match as being the sides of a right triangle. The perimeter is 36, 9 plus 12 plus 15, and the area is 54. Yep. Okay. This is the symbol for must go to washroom. Okay, let's use that. And yeah, go ahead. Okay. Just use it. It's a timeout, whatever. It's just that way. It's not a hand, which I think, oh, somebody's actually, you know, asking a question. And then it's like, yeah.
Why not a fist or something?
Well, I don't know. There are other signs we could make. But show me a sign. Okay, so from the diagram, we had 2x, so that's 12. We've got 2x minus 3, right? So that's 9. And we've got 2y plus 1, so that's 15. Okay, so perimeter is 9 plus 12 plus 15 is 36. Are there units on this? Centimeters, yeah. Oh, perimeters, oh, I just found the perimeter is 36, which they didn't ask us to find because they told us that.
Oh, yeah, we're supposed to find the
Really? Well, find the link, find the perimeter. It's here. Yeah, actually. Okay, but that's a good check back, right? So there's two check backs here, right? One is, did I get numbers that do add up to 36? Yes. The other is 9, 12, 15 a Pythagorean triple? Yes. Okay, good. The area, lengths of the sides, okay, so we've done that. There's the length of the sides, perimeter. Area is 1/2 base height is 1/2 of 12 times 9 is 54 units. No point in losing half a mark for units, right? So put them in centimeters squared. Questions? Right? And if you need to see this again, it'll be up on YouTube later.
And then would we just put the diagram to represent the sidelines?
Yeah, you know, if it's there, I think just, you know, listing them up there, if you squeeze it in somewhere, so, you know, oh my God. Why? I'm gonna pause. I know, but that "the" was actually there and then it just went. So either cross off those or add this. It's either we're going to use the direct article everywhere it belongs, or we're just taking the direct article out. All right, the graph below. So I'm guessing this is the watermelon. I'm not guessing. That's the watermelon. This is the archer. We should probably have a if the graph. Where's it? Shows it. What is? I forgot what we're doing. Then algebraic term the height of the watermelon when it is pierced by the arrow. So you look at that. All right. So if you get an answer something a little bit below 14, you know you probably solved this correctly. How are you going to solve this? You're going to say, well, we have quadratics, right? We're going to solve this in such a way that we are going to review the first unit at the same time, right? Nice. So this is a really good question because not only does it solve a system, but before we get there, we're reviewing a chunk of, okay? So let's list some stuff here, right? This is the point 0, 20. This is the point 2, 16. This is the point 0, 2. And this is the point 2, 0. Okay? Probably should have used different colors, but I didn't. And neither will you because you're just using a pencil. Okay, so watermelon. Y is equal to A, x minus p, quantity squared plus q. So you say, okay, I know the vertex of the watermelon and I know a point on the graph of the watermelon, which means that I'm going to find the vertex form of this equation, right? Which is, so here's how I do it. You don't have to do it this way. I mean, you could put more stuff. I like to just start with sort of a generic. Y is equal to A, x minus 0 squared plus 20. So I like to fill in my p and my q first, because it tells me, really, I'm just going to be writing this exact same line again. I just won't write minus 0 because that's silly, and I will have a value for A. But this is what my equation is going to look like. I'm just going to have a value for A. So now we got to figure out what's the value for A. So we take a point on the watermelon graph, which is at 2, 0. So we substitute 0 is equal to A, 2 squared plus 20. What is the sign of A? We know it's negative, right? Okay, good, because we're about to get a negative. So negative 20 is equal to 4A, and A is equal to Negative 5. And our equation for the watermelon is y is equal to negative 5x squared plus 20, which is in both vertex and standard form all at the same time, right? Nice. So we didn't have to bother converting it to standard form because that's pretty much standard form. Now what? Now we do the arrow, which can be seen on Wednesday nights on CTV or CTV2 or whatever. And we write y is equal to a, x minus p squared plus q. I think you guys just want to save pencil lag. You know, it's like, seriously, I'll loan you a little pencil. Just write more stuff down. You never write enough. All right, so what am I looking for? I'm looking for a x minus 2 squared plus 16, right? So I'm filling in p and q, right? And we know that it moved 2 units to the right, so it's got to be x minus 2, and it moved up 16 units, so it's got to be a plus 16. And there's a point on this graph, which is where? 0, 2. So we're going to plug in a 2 for y and a 0 for x. And we know that a is negative because this also opens down. Okay, so 2 is equal to 4a plus 16. 4a is equal to negative 14. I'm going to subtract 16 from both sides. And so a is equal to negative 14 over 4 or negative 7 over 2. And now I go back to this line here, and I just put in the a. So I've got y is equal to negative 7 over 2, x minus 2 squared plus 16. And then I say, well, I can solve this by comparison, right? Since I know what y is equal to, and I know what y is equal to, and what I want to find is when these two y's are equal to each other, I'm just going to set them equal to each other. But I'm not going to do it with this, right? I need to convert from vertex form to standard form. No, God, you're not completing a square, you're just squaring it. Yeah.
Can we just put like these two into a calculator?
No, because you can't solve it graphically. It says algebraically determined.
Does it? Oh, it does.
You may verify it in your calculator afterwards, right? Like if I had time, I would, right? Usually I have time because I work a lot faster than you all, but yeah, a lot of times I will punch it in my calculator and just say, and when you do that, set the window to look like this, okay? What I would do is graph 3 things, right? Graph this and just say, do I see that on there? Yeah, it looks like it, okay. You know, you're looking for something that goes through here and here, right? So if you set your window to go 0 to 22 by 2s and blah, you know, negative 1 to 4 by whatever's, right? When you graph that line, and then you can graph this line, but more importantly, okay, so now we've got to, what's x minus 2 quantities, what's x minus 2 quantity squared? X squared minus 4x plus 4. Okay? So when we square these, now look, if you need to write it out as x minus 2 times x minus 2 and then write x squared minus 2x plus 4, do it. Okay? So, quick way of squaring a binomial is you square the first term, x squared. You take these two multiplied by each other, so x times negative 2 is negative 2x, and you double it, minus 4x. And then you square the last term, plus 4. That's 16. Now what? Multiply everything by 2, or negative 2 even. Okay, wait, I don't know, hang on. So I've got a y equals. If I leave this, I could just equate the two equations. Right? Well, I've got this y equals, and I've got this y equals, right? Really, at some point, I need to set them equal to each other and solve. And the problem is, I've got that 7/2, which is, if I multiply through by 2, this will become 2y equals. But I'm going to anyway. Wait, let me look and see the solution. Maybe they did something smart. Yeah, they multiplied through by 2. Okay, actually, here's what they did. So they said, all right, we got a y equals negative 5x squared plus 20. And we got another y equals negative 7 halves x squared minus 4x plus 4 plus 16.
Oh,
Okay? Yeah, we get 2 y's, right? This is called the method of comparison. It's really substitution, right? But actually it's a subcategory of substitution, so we call it comparison, right? If y is equal to this and y is equal to that, then we know that this and that must be the same thing, right? We can set them equal to each other. Okay, I am not going to handle a 2 in the denominator, so I'm going to multiply everything by 2, right? So this becomes negative 10x squared plus 40 is equal to negative 7 times
it's
32. Yes, good. That was on purpose. I was actually trying to. I'm better than that. I did, right? Because the terms of the there's really two terms. There's a negative 7 halves and then there's a blah, right? Like take the x squared minus 4x plus 4 and just say that's like a capital B. So I've got negative 7 halves times b. If I multiply that by 2, then the 2's go in. I've got negative 7 times b, right? Like something. Okay. Don't get too fancy. Just say I'm going 2 times this term. Right? And when I multiply that by 2, this just becomes a negative 7. This stays the same. Okay? Right? Otherwise, you're going to multiply by 2 twice, and then it's just going to get ugly. And bad, and then sad. Okay, so now we're just going to do some algebra. Do some algebra. So expand the right-hand side. Collect all the terms. Get everything over to one side. Aim for a positive x squared. Get it equal to 0. Hope that it factors. Know that it probably doesn't because it's a time, and really, when is time? Or it's a height at a time. But we need to find the time so that we can find the height. Maybe it factors. Nope, it doesn't factor. It's okay, because this is really good practice for quiz 2, right? Solving using, sorry. So negative 10x squared plus 40 is equal to negative 7x squared plus 28x minus 28 plus 32. Okay? Don't do too much at once. Okay? One of the biggest problems that, where people go wrong is just do too much at once. Yeah, I'm going to multiply it by 4 and then I'll add the 32 at the same time, and all of a sudden it becomes plus 60 instead of plus 4. Because, you just don't do too much at once. If you need paper, we have stacks of this stuff, right? I mean, I hate it when you use graphics. I squeeze all my work, but if you can squeeze, everything's done on here. Like seriously, every bit of work I've done on the multiple track, that's all in there. Okay? Now, if you can't write that small or you choose not to, then that's fine, right? Use the scrap paper. But show lots of work. Okay, what are we gonna do? I'm gonna move this over, right? So I'm gonna add 10x squared to both sides, right? That's gonna give me 3x squared. The x term stays the same. I might want to work this out here. Just say that's plus 4, right? Because I'm now going to subtract 40. Okay, and this was 4. So 4 minus 40 is negative 36. And that's equal to 0. Okay, so I moved the negative 10x squared over here. Became positive 10x squared. 10x squared minus 7x squared is 3x squared. There was no x term to move over, so the plus 28x just stays. The 40 has to be subtracted. So I can either do negative 28 plus 32 minus 40. You can do that in your calculator, right? Or I can just say, hey, these two guys are 4, and I'm subtracting 40, and we get this. And we say, it's not going to factor, is it? How do you know if it factors? Well, you could do a b squared minus 4ac, right? You just sit there and go, what's 28 squared minus 4 times 3 times negative 36? And it won't have a square root. And then you'll know, since the discriminant doesn't have a square root, then this thing won't factor. Right? I have to use quadratic formula. So either you spend 30 seconds trying to factor it, or you look at it and say b squared minus 4ac is greater than 0, which is good because that tells me there are two solutions, only one of which I want, right? Or does it tell me there are two solutions? I don't know. Maybe there's only one solution. Okay, there's two solutions, right? But we're only looking for one. Okay, so they'll cross here and that somewhere in negative time space down there, right? They'll also cross. But in the context of the situation, we're going to reject one of the solutions, right? So we'll show it, then we'll reject. All right, so what do? We say A is equal to 3, B is equal to 28, and C is equal to negative 36. We pull out our formula sheet, or it's written at the top of the test, or we break out, pop goes the weasel. And we say x is equal to negative. It's one of my math songs. Where is he? Oh. I knew that long before. I know pi to like 2 lines on this shirt, which isn't all that much, but still, it's about 160. Well, I wrote it up there. Okay. X is equal to negative 28 plus or minus the square root of 28 quantity squared minus 4 times 3 times negative 36. Remember the thing we did the other day? If A is positive and C is negative, you know there's two solutions, right? Because this has to be positive. Doesn't matter what B is. B squared is positive. When you're going minus and that's positive and that's negative, then you're really going plus. Okay? All over 2 times 3. What was the actual question? Then algebraic determine the height of the watermelon when it is pierced by the arrow. So we're going to find x. We're going to substitute that into either equation to get y, right? That's, I mean, you know, by this time it's like, what are we even doing? Okay, so x is negative 28 plus or minus, what's 28 squared? I'll look on the sheet here. 784. What's 12 times 36? 316, 72. 432. That one isn't actually written here. I had to do that. Plus 432 over 6. So x is equal to negative 28 plus or minus the square root of, what do we got? 6, 1, 12? 12, 16 over 6. So it's negative 28 minus the root of 1216 over 6. Reject. That's negative, right? You got a negative minus a negative. That's out of the context of the question, right? If I had just given you these two equations and said solutions, you'd have to give me two solutions. Okay, so you go, so x is equal to negative 28 plus the root of 1216 over 6. I don't even know what we're going to do with that. So I'd get a decimal for it. Okay, they never really said what the answer should be, rounded to or anything, right? So it's determine the height. Okay, so let's just go work that out as a decimal. Plug that into, what's an easy one? We just need a y equals. Plug that into here, right? Y equals negative 5x squared plus 20. So work this out. So use calculator. Okay, plug x value in, plug x in, y equals 5x squared plus 20, and you get y equals, are we there yet?
Wait, wasn't
We're trying to find the height. Yeah, I know, right? We're trying to find the height, right? So we have this, right? This point here is negative 28 plus the root of 1216 over 6. You're going to plug that in your calculator and work it out. You're then going to take that number and you're going to go 5 times second function answer squared plus 20, and you're going to get this, which is, I await your answer. 13.4. Units? Meters. Okay, is that reasonable? You look at the graph and yeah, right, it's less than 14. It's more than 12. It's bigger than a bread box, but it's a watermelon. I don't know how big it watermelons are bigger than bread boxes?
What?
I don't know. It's like late on a Friday. It's nothing. It's got nothing to do with nothing. It's like I don't even know what the problem was, right? Like we're so deep into this
We
thing.
get asked these questions.
Yes, yeah, of course we get asked these questions.
This took like 15 minutes.
I'm